Hey guys, it's Lloyd from Brilliant by Design here, and this is the first in a series of videos that I thought I might do, just to share what I'm doing in SketchUp and connect with other people who are passionate about SketchUp and also building. So I'm a builder by trade, and I've been using SketchUp. Um, Actually, I used it as a carpenter when I first started my apprenticeship, and then I've used it ever since. And it's got to a point now where I've just decided to move off the tools and into modeling for other builders so that I can help them to leverage the software um, for the benefit of their businesses. Now, this model here that you see in front of you is a current project. It's a house in Wollongong being built by James Madigan of Innovation Building Design. And James is really passionate about incorporating um, this technology into his business. And we've been working together for some time, really trying to integrate it into his workflow and into their systems. We got the architecturals for this job from a local draftsman, and the first step for us is we basically do a quantity model. So we draw the job up as a concept, and we generate all our quantities from that so that we can provide the client with a really accurate quote so they can visualize the job, and so that we can make sure there aren't going to be any issues with the build. And then once the client has agreed to the job and signed contracts and such, we move into the structural modelling phase. And this is where this is at the moment. It's not finished, but it's getting pretty close now. So I thought that I might share it with you. And the benefit for us of this is that it allows us to basically build the job, have a practice run if you like. So we're able to really carefully design this so that it's value engineered, so that it's efficient to build, and also just make sure that there aren't any problems. And then once construction starts, this model will be used on site by the site supervisor, by the foreman, by the carpenters, and any other subcontractors who may need to quickly see and understand what they're doing. One of the huge benefits of something like this is just the level of communication that it provides. If you're a builder, you'll know that it's often hard communicating with all the people that you have working for you. And even the best communicator struggles to explain things to people. It's very hard to picture things in your mind. It takes years of experience and training to be able to understand something from 2D drawings or picture something from a conversation. But a model like this really takes away all the guesswork. So let me just step you through this model and how it works. I've set this up in a scene so that it's very quick and easy to navigate. If we go under this first lot of scenes, this is just the line work straight out of the architecturals. And so I use this as a datum, and I check this very carefully with the architecturals to make sure that I'm drawing things correctly. So that's what they are. Then we've got this scene here, which is what I call the RL reference scene. So over here I've drawn these planes which represent all the floor levels, and they go off this plane right down here, which is an RL. And then I've lined up these planes with the floor levels of my job. If I was to grab this plane and drag it across here and place it on the floor, you can see how those planes line up exactly with the floor level. So again, that's just a way that when I'm setting out a job, I can ensure that what I draw is actually exactly what has been specified by the architect or the draftsman. And moving through the model now, so this a big part of this model will actually be the carpenters will use it to build the frames on site. So a big part of this model's job is actually as a framing reference for the carpenters, and we also produce a full set of framing plans with cut lists so that the carpenters can just get in there and get that job done really quickly. Now you may wonder why on earth we'd want to build frames on site, but in my view, with this technology and the accompanying documentation, we can actually build frames very quickly and to a very high standard. any builder will know that hand cut frames on site are far better quality than those produced typically from a frame and truss company. And it also means that carpenters are able to solve problems on site as they build the frames, rather than have to pull apart pre-made frames and trusses which may have been made wrong. So all the frames for this job will be stick built. So if I jump into the framing, the frames have been isolated onto their floor levels, because as a carpenter I would probably focus on a floor level at a time. So this is the ground floor, then we've got level 1, level 2 and level 3, and then these scenes here actually isolate out each frame. So this is the first frame on the ground floor, so it's isolated out, and I can grab a tape measure and I can measure whatever I want. If I wanted a diagonal of this frame to make sure it was square, I can get that measurement. I could measure any bit of timber and check things, and I can also zoom around in 3D and see how it's put together. And you can see there that we've got a 250 PFC beam. Now if I jump back to the ground floor frames in 3D, you can see that that frame sits at the front of the garage. If we go to this frame, okay, which is frame 2, and I go up to my scenes here and I go to frame 2, there is frame 2. So it's actually quite easy to navigate around once you understand how this model works. Let me show you a little bit more than framing. So we set the model up so that it's very easy for anyone to find the information that they want and isolate things off. So I'm just going to switch off the wall frames, and then I might switch off the brickwork and the flooring, and let's say the slab and the stairs. So we just want to look at our joists at the moment. So let's say I'm a carpenter and I'm going to be laying these joists out. You can see that the joists are all in their levels and laid out, and I might want to actually check these joists with my line work. So what I'm going to do is I'm going to turn the line work on, and there you go. I can see that the joists are working with my floor plan or my line work, and maybe I want to check that for the next level up. So I'm just going to carefully move that up on the blue axis, and I can see how my floor plan is overlaid over that section of the floor. And then again we can jump up to the top floor. So it is very easy and quick to get the information you want. Perhaps I'm just building this floor level here, so in that case I might only want to see that. So I'm going to isolate out all the other floor levels, and maybe I want a top-down view of that floor for the purposes of a drawing or some measurements, and there you go. I can generate that very quickly and easily. So again, having a really well organized model like this is just amazing for a builder. It gives them so much information and the ability to communicate really clearly and effectively with everyone involved in the process. But let's keep stepping through the model. So we'll turn the slab back on, the stairs, which I've only done one set roughly, the steel work. Let's turn on our floor system, and you can see the detail here. Eventually I'll have a hanger on each of those joists. I just haven't done that yet, but we literally try to draw it exactly how it will be built. Let's go with our flooring and our brickwork, and back to the wall frames. So anyway, I hope this has been of interest to you and helpful. I certainly believe that 3D modeling is the future, and I think for the building industry particularly, detailed structural modeling is just invaluable. And yeah, I'm excited about getting alongside Australian builders and helping them to leverage this technology to make their jobs more efficient, to make sure their clients are happier and more satisfied with the process, and ultimately to increase the quality of building in Australia. Thanks for your time.